Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you guys through how to solve each of these quadratic equations on our first quiz review for the quadratics unit. So as always with my disclaimer, please do not watch this video and just copy down what I do. I need you guys to actually work the problems first on your own, and then when you get stuck, you need some extra help, then come back and watch the video to iron out any misunderstandings or to simply check your answers and make sure your thought process is correct. So as always, I like to throw something kind of funny up here on the screen. If you guys can conquer and master all 7 of these quadratic equation methods, then this is the little happy dance that you need to bust out into. Yeah, right there. If you can master the quadratics unit, then that needs to be you right there. Oh yeah. Okay, all right, let's jump on in here. So I have my little cheat sheet, which is the same poster that I have up in my room for the 7 different methods for solving quadratics. So that's what makes this unit so difficult, is not only are there 7 different methods, and some of these methods are kind of complicated, but you've got to figure out which of these methods are the best and most applicable. And you got to know what to look for to decide which of these methods to use. So just to refresh our memory, number 1 is the GCF method. Then we have special case, square root method, factoring a trinomial where a is 1, factoring a trinomial where a is not 1, where we do the curtain thing, the grouping. Number 6 is quadratic formula, and finally, in my opinion, the hardest of all the 7 is completing the square. All right, so let's jump right in here looking at number 1. So I got to figure out which of these methods is the best for solving number 1. So let's go down through our list. Can I use the GCF method on number 1? No, I can't, because you got to remember, and get out your study guide that I passed out to you guys as we're going through these. Remember, with the GCF method, you can't have that C term. Okay, I can only have a squared variable and the single variable. So I can't use GCF. It's not a special case because I can't take the square root of 5. I can't use the square root method because there's a middle term. I can't have that B term there. Factoring a trinomial where a equals 1. Are there any factors of 5 that add to 6? Well, yes, there are. The only factors of 5 are 1 and 5. And if I add 1 plus 5, yes, I do get 6. So you got to ask yourself, what times what gives you 5? And at the same time, what plus what gives you 6? And that's easy. It's literally just 1 and 5. 1 and 5. So when you're factoring a trinomial where a equals 1, all you do is, what are the factors of that guy that add to that guy? Okay, and once you find those two numbers, that's literally how the trinomial factors. It just factors as x plus 1 and x plus 5. Okay, now in chapter 11 we stop there. Okay, but in chapter 12 I got to set this equation equal to 0. And once again, when I have my 2 binomials, when that leading coefficient inside the parentheses is a 1, what do I do with the signs? I flippy flip. So I just flip the 2 signs, I get -1 and -5. And those are the 2 numbers that I can plug into my equation that will satisfy that quadratic. Okay. I'm not necessarily going to check every single one of these guys. I've shown you guys how to check these in class, but you would just simply take both of these answers and plug them in for x and make sure that it equals 0. Okay, but sake of time for the video, so this doesn't become an hour-long video, I'm not going to do that. Okay, so number 2, let's go down through our list. Number 2, can I use the GCF method? Actually, in this one I can, because remember the GCF, I can't have that C term. Okay, so if we look at our standard, let me just write that up at the top, ax squared plus bx plus c equals 0. Okay, so remember, with a quadratic equation where I don't have that c term, when that guy is missing, and I just have the r squared minus the 7r, I can use the GCF. So all I literally do is pull out the GCF, which is an r. I'll factor out an r. That's going to leave me with an r minus 7. Our 0 product property says when 2 things multiply to give you 0, either that guy is 0 or that guy is 0. So I set each one equal to 0. If I set r equal to 0, I literally get r is 0. And then the other one, there's a 1 there, so what do I do with the sign? I just flippy flip. I just flip the sign. So I get 0 and 7. So again, some of you guys are asking in class, why can't we just use the quadratic formula for every single one? You can. Completing the square and quadratic formula work for any quadratic on planet Earth, but why in the world would you go through some long, complicated procedure and process when you can do one of the easier methods that you can do in, say, 10, 15, 20 seconds? And I'll tell you guys, if you try to use the quadratic formula on every single one on the quiz or on a test, you're just not going to have enough time, okay? And that's part of the learning process here, is trying to figure out, in life and any job that you have, there's going to be an easy way to do it, and there's going to be a hard way to do it a lot of times, and it's not going to go well for you if you're always taking the longer approach. And your boss gives you something to do, and it always takes you 3 hours when it should take you 30 minutes, or it takes you 2 weeks when it should take you 2 days. So that's part of the learning process with education, is making sure that you're being as efficient as possible and using the most appropriate, applicable, and the quickest method, the easiest method to make your life easier. Okay, so number 3. Okay, can I use GCF? No, because I have a C term. Is that a special case? Well, let's see. Yeah, I can take the square root of that. I can take the square root of 1, but when I multiply 1 times k and double it, I don't get negative 4k. Okay, so I can't use the special case. Can I use the square root method? No, because I have a B term. Factoring when a equals 1. Are there any factors of 1 that add to negative 4? Nope. I can't factor a trinomial where a is not 1 because a is 1. There's an understood 1 there. So now the first 5 methods are exhausted. I have to either use the quadratic formula or completing the square. Okay. So in my opinion, when there's a leading coefficient of 1 there, you can use the completing the square method. But if that leading coefficient is not a 1, if there were a 2 in front of there and you can't use these 5 methods, please use the quadratic formula. It's just going to make your life a lot easier. Okay. It's up to you guys. On the quiz, I'll let you choose. You can either use quadratic formula or completing the square. I'm going to work this one by completing the square just because I know some students prefer that method. So with completing the square, you're going to have to know the 5 steps. The first step is to isolate the constant. So I need to move this 1 to the other side. Goes cancel. This is the only method where I don't want my quadratic set to 0. So I have k squared minus 4k, and if you remember, I have a what? I have a plus blank, okay? And then I have the negative 1, the isolated constant, and then I'm always going to have a plus blank on the other side. Okay, step number 2 is make sure the leading coefficient is a 1. Thank goodness it is, because it gets a little bit sticky when it's not 1. Step 3 was, how do I complete the square? It's half of b squared, half of b squared, half of b squared. What is my b? My b is negative 4, so it's negative 4, half of that, which is negative 2. Negative 2 squared is a 4. Okay, so 4 is the magic number that I'm pulling out of thin air. I'm going to put a 4 in that blank. I'm going to put a 4 in that blank. And now I have completed the square. The whole purpose of doing all that is to take something that's not a square, and now I have forced the guy in the box, I have forced that to become a perfect square trinomial. That's why we completed the square. How does this perfect square trinomial factor? I know it's going to factor as a parentheses squared piece, so you can just go ahead and write that down. And the number that goes in the parentheses squared is just half of b. So my b is negative 4, and we're using k's, so half of negative 4 is negative 2. So it just factors as k minus 2 parentheses squared. On the right hand side, I combine my like terms, equals negative 1 plus 4 is 3. And the last step is to take the square root of both sides. When I take the square root of something squared, I just get itself. So I just get k minus 2. And then when I take the square root of 3, I'm always going to generate a plus or minus. So I get plus or minus the square root of 3. Now I still need to get k by itself, so I'm going to add 2 to both sides. Okay, they cancel. I'll come over here. So now I have k is equal to this 2 that I added to both sides, plus or minus the square root of 3. Now, that's the exact answer. That's the perfect answer. If you want to convert this to a decimal, you're more than welcome to do that. But if you do that, then you've got to do both the positive and the negative version. So I literally, on my calculator, I would have to type in 2 plus the square root of 3, and that gives me some number. That comes out to be 3.7. And then I have to do the negative version. I have to do 2 minus the square root of 3, punch that into my calculator, and that gives me 0.7. All right, so let me grab my calculator real quick, just to show you guys real quick what I'm talking about there. So I've got 2 plus or minus the square root of 3, so I'm going to do the positive version, 2 plus the second square. By the way, the square root button is right here in blue above the x squared. So you have to press second square root, 2 plus the square root of 3. That gives us the 3.7 number, and then I have to do 2 minus second square root 3. And that gives us the, that should be, actually that should be 0.3, not 0.7. Yep, change that real quick. 0.3. So 3.7 is 0.3 for the decimal. Okay, so let's move on to the second one here. So I've got number 4, I've got n squared minus 3n minus 18. Okay, so let's go down through our list. GCF, no. Special case, no. Square root, no. I've got a b term. Factoring when a equals 1. Are there any factors of negative 18 that add to negative 3? What times what gives me negative 18, and what plus what gives me negative 3? Well, I've got factors of 6 and 3. Now the question is, which one's positive, which one's negative? Remember, the middle term, the sign of the middle term determines the sign of the bigger one. So the bigger one is 6, so that one's going to be negative. Negative 6 times 3 gives me negative 18, and negative 6 plus 3 gives me the middle term, negative 3. And so when you're factoring, when a is 1, guys, when that guy's a 1, all you do is find those two numbers, and that's what goes in your two binomials. Negative 6 and 3. We're using n's, so it's n minus 6 and it's n plus 3. Set my quadratic equals 0, and then all I do is just flip those two signs. Flippy flip. Positive 6 and negative 3. No reason to do quadratic formula on that. Absolutely no reason when you can easily factor it. Number 5, can I use the GCF method? No, because I have a constant. I have a c term. Special case? No, that's not a special case. What about the square root method? Notice I don't have a b term. I have a v squared, but I don't have a single v anywhere. So in this case, I can use the square root method. And all I need to do is I need to get this v squared by itself and take the square root of both sides. So I'm simply going to move this 3 other to the other side. I get 81 v squared is equal to 100. Okay, I need to get the v squared by itself, so I'm going to divide both sides by 81. I get v squared is 100 over 81, and then the square root method. I'm literally going to take the square root of both sides, and I'm going to get v is equal to, whenever I take the square root of a positive number, I always get plus or minus. Okay. Now, if you want to keep this as a fraction, you can. The square root of 100 is 10 over the square root of 81 is 9, so you could just leave it as plus or minus 10 ninths, leave it as a fraction. If you want to convert that to a decimal, you could leave it as plus or minus 1.1 bar, 1.1 repeating. Either of those would be correct. I would accept either of those on a test or quiz. That's the square root method when there's no middle term. Okay, number 6. GCF, no. There's a C term. Special case, no. I can't take the square root of 24. Square root method, no, because I have a middle term. What about factoring? Are there any factors of 24 that add to negative 10? What times what gives me 24, and what plus what gives me negative 10? And there are 6 and 4. Since they multiply to give you a positive 24, they both have to either be positive or they both have to be negative, and since they have to add to a negative, that means both of these guys have to be negative. Negative 6 and negative 4. Okay, so once again, when that's a 1, when you find these two numbers, just bam, just throw them into your two binomials. We're using r's, so I've got an r and an r, and it's just r minus 6, and the other factor is r minus 4. That's how it factors. The leading coefficients in the parentheses are 1, so I get to flippy flip. Flip the signs, 6 and 4. You can take both of these answers, plug in 6 squared minus 10 times 6 plus 24, and that will equal 0. Take your other answer, plug it in for r, and make sure it equals 0. Okay, let's move along, Okay, so down here, number 7. Get this out of the way here. All right, I've got x squared plus 8x plus 14 equals 0. Okay, so let's go down through our list. Can I use the GCF? No, because there's a C term. Special case? No, 14 is not a perfect square. Square root? No, because there's a middle term. Factoring when a equals 1. Well, a does equal 1. What are the factors of 14 that add to 8? 1 and 14? No, that doesn't get me an 8. What about 2 and 7? No, that doesn't get me to 8. So there are no factors of 14 that add to 8. So I can't do 4. I obviously can't do number 5 because number 5 is when a is not 1 and a is 1. So now we're down to either quadratic formula or completing the square. Okay. So once again, since the a is a 1 here, either one is fine. I'll do completing the square again. I'll do the quadratic formula on maybe the next couple of ones where we have to use one of those last two. But let's go ahead and complete the square on this one. Step 1 is to isolate the constant. Let's move this 14 to the other side. So I have x squared plus 8x, here's the blank, plus blank is equal to negative 14. Here's another blank. I have two plus blanks on the left and the right. Step 2 is make sure the leading coefficient is 1. It is. Step 3 is take half of b squared, half of b squared. Okay, my b is the 8. Half of 8 is 4. and 4 squared is 16, so that's the magic number. So I'm going to stick a 16 in that blank. I'm going to stick a 16 in that blank. Okay. Now, why did we do all that? So that now I have forced that guy in the box to become a perfect square trinomial because we completed the square. So now how does this factor? I know it's going to be a parentheses square, so just go ahead and write that down. It's an x, so I'm going to x, and the number that goes in the parentheses squared is just half of b, half of that number. Half of 8 is 4, so it's an x plus 4. On the right hand side, I'm simply going to combine my like terms, negative 14 plus 16, that gives me a 2. And the last step is to take the square root of both sides. The square root of anything squared is just itself, so I'll get x plus 4. 2 is not a perfect square, so I'm just going to leave it plus or minus the square root of 2. And then I'm going to subtract 4 from both sides. Those cancel. So I'm going to have 2. I'm going to have my exact answer. If you leave this now on a test or quiz, if you want to leave it as a radical, I'm perfectly fine with that. I've got this negative 4. And I have the plus or minus the square root of 2. Okay, that's a perfectly acceptable answer. Okay, that is the exact answer. There's no rounding, there's no decimal. If you prefer to convert this to a decimal, especially for those of you guys that want to plug your answers back in to check, it's kind of hard to plug all of this in, to plug that in for x. Okay, so if I were you, I would go ahead and convert this to a decimal so I can stick in the decimal for x and check and make sure my equation equals 0. So if you plug this in a calculator again, let me just do this again for you real quick. Slide this over. I'm simply going to do negative 4 plus the square root of 2. I'm going to get an answer. That's negative 2.6. Negative 2.6. And then it'll also be negative 4 minus the square root of 2. Remember, with quadratics, most of the time I'm going to get 2 answers. So that's going to be negative 5.4. And I'll accept this on a test or quiz as well. Well, test is multiple choice, but on the quiz, of course. So either the exact answer or the 2 decimal versions is fine. Okay, number 8. Okay, let's get out our little cheat sheet. All right, so move my keyboard over here so I can get some more. Okay. All right, so I have 2n squared minus n minus 6. All right, GCF? No, because there's a C term. Special case? No, 6 is not a perfect square. 2 is not a perfect square. Square root method? No, because there's a middle term. Factor when a equals 1. Okay, well, a doesn't equal 1, so obviously can't do that. What about number 5? Factoring a trinomial where a is not 1 using the grouping method. Let's check that one out. This is the rainbow thing. Let's just check it out. If I do the rainbow, multiply a times c, 2 times negative 6 is negative 12. Are there any factors of negative 12 that add to negative 1? Well, what are the first 2 numbers that pop in your head when you think about 12? I think about 3 and 4, right? Well, 3 and 4 will get me to a 1. Okay, so 3 and 4, those are factors of 12 that will get me to a 1. Now, since this is negative, since the c is negative, that means one of these guys is positive, one is negative, and the middle sign determines the sign of the bigger one. So the 4 has to be negative. Okay, so in this case, I can do the grouping thing. I can do the curtain thing, and to me, that's quicker and easier than using the quadratic formula. Although that will work. Okay. Okay, so when I get these 2 numbers here with the grouping thing, the whole purpose of getting these 2 temporary numbers is so that I can split the middle term. Okay, so I'm going to split this negative 1. I'm going to bring down my 2n squared. I bring this guy down. I bring down my negative 6, and now I'm going to split. I'm going to choose to match up the negative 4 with the 2. So I have minus 4n. I'll match up the 3 with the negative 6, so I have plus 3n. So once again, all I've done is I split negative $1. I split that into negative $4 plus $3. Okay. All right, so the whole reason for doing all that is so now that I can draw my curtain. Now I'm going to rewrite this, since this is kind of in the way. I'm just going to rewrite this down here. 2n squared minus 4n plus 3n minus 6. Now I'm ready to draw my curtain in group. Pull out the GCF on the left. I can factor out a 2. I can also factor out an n. Hopefully y'all are good at this by now. That's going to leave me with an n minus 2. Over here, all I can pull out is a 3. Guess what? That will also leave me with an n minus 2. They match. That's good. So it factors. One of my factors is the matching binomial, and the other factor is the stuff left over on the outside, the 2n plus 3. But once again, we got to set this equal to 0. Okay. So now, let's move this down a little bit. All right, so now since this is a leading coefficient is a 1 right here, all I get to do on that is what? I just get to flippy flip. just flip that sign. But over here, I can't just flippy flip because that is not a 1. I have to literally come out here to the side and separately set this little mini equation, set it equal to 0. 2n plus 3 equals 0 and solve. So move 3 to the other side. 2n equals -3. Divide by 2. And my other answer is -3/2. So I get 2 comma -3/2 or -1.5. Either one of those would be fine. Okay, so that's the Curtin method, solving by grouping. To me, that's a little bit easier than using the quadratic formula. Okay. All right, so let's continue on to the back here. Halfway home, halfway home. I know this is tough, guys. It's tough. Tough unit, tough unit. Persevere. We can do it. You can do it. Gotta believe. Okay, number 9. Let me turn my page over here. Okay, number 9, GCF. No, because I have a C term. Special case? Huh. Wait a minute now. Wait a minute. Can I take the square root of that? Can I take the square root of v squared? I sure can. Can I take the square root of 36? Is that a perfect square? Sure is. That's 6. When I multiply 6 times v and double it, do I get a 12? Yeah, I sure do. So this is actually a special case. So all I do is, just like we did in chapter 11, I throw a parentheses squared around it, and I just drop the sign. Since that's a negative, that's a negative. Okay. So now I've got v minus 6 squared. Okay, so if I just take the square root of both sides, I just get v minus 6 equals 0. And how do I get v by itself? I just add 6 to both sides. V is equal to 6. So this is one of the few times, guys, where normally have 2 answers. Sometimes we have no real solution when I'm trying to take the square root of a negative. This is one of the rare times where I literally only have one number. There's only one number I can stick in for v that will make this equation equal 0, and that number is 6. Okay. All right, so let's move along. Number 10. Okay, GCF, no, there's a C term. Special case, no, that's not a perfect square. Square root, no, there's a middle term. Factoring when A is 1, no, factoring is not 1. Factoring a trinomial where A is not 1. Okay, now I'm looking, these are some pretty big numbers. If I were to do 8 times 38, that's going to give me some huge number. So in my opinion, this would be a great candidate for quadratic formula. Don't try to complete the square when that guy is not a 1. Okay, it gets really, really nasty. All right, so I'm going to use quadratic formula. All right, so the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. I know y'all can't get that out of your head. Come out here to the side. My a is 8, my b is 5, my c is negative 38, and I'm simply going to plug these into my equation. All right, so I've got let's go negative b, my b is 5, so I've got negative 5 plus or minus the square root of b squared, so the 5 is b, so it's b squared, 5 squared, minus 4, it's always going to be a minus 4, times a, which is 8, times c, which is negative 38. Okay, all of that, the entire thing is all over 2 times a, or 2 times 8. Okay, so now let's continue simplifying. So I've got negative 5 plus or minus. Now again, if you guys want to do this manually, you can kind of do it one step at a time, or if you just want to plug all of that into your calculator. Let me just circle this in green here. If you just want to type just this stuff in green into your calculator, you can do that. Type it in exactly the way you see it underneath the radical. Okay, so I can type in 5 squared minus 4 times 8 times negative 38 and get some number. That gives me some huge number. Okay, 1,241. Okay, that's underneath the radical. The stuff in green is still under the radical. 1,241. Okay, and so all of this is over 2 times 8, 2 times 16. Okay, now once again, let's see if I can take the square root of 1241. Square root of 1241. Whoops, sorry. Square root of 1241. No, that's some decimal. Okay, so I can't take the square root of that. So if you guys want to leave this as an answer, as the exact answer in a test or quiz, that's perfectly fine. If you want to try to type in both of these and get a decimal like I've shown you earlier in the video, then you can type in negative 5 plus the square root of 1241 divided by 16 and get a decimal. And then the negative 5 minus the square root of 1241 over 16 get another decimal. And those two decimals come out to be 1.9 and negative 2.5. So those are the decimal versions of that answer. Again, you may want to do that if you're one of those students that want to plug your decimals back in and check and make sure it equals 0. But the exact answer will work fine as well. Okay, let's continue. Number 11, r squared minus 10r minus 15 equals 0. Okay, so let's pull out our cheat sheet here. GCF, no, because there's a C term. Special case, no, because that's not a perfect square. Square root method, no, because there's a B term. Factoring when A equals 1. Are there any factors of negative 15 that add to negative 10? 5 and 3, that doesn't do it. 15 and 1, that doesn't do it. So I can't factor it. I can't do the grouping because A is 1. So now, once again, I'm down to quadratic formula or completing the square. So now, once again, since this is a 1 there, completing the square would be fine. So I'm going to choose to complete the square on this one. I'm going to isolate the constant. I'm going to move the 15 to the other side. All right, so I've got r squared minus 10r, here's the blank, plus blank equals 15 plus another blank. All right, what goes in the blank? Half of b squared, half of b squared. All right, so I've got to take half of negative 10, which is negative 5. When I square negative 5, guys, when you square something, you always generate a positive value every single time. So a 25 is going to go in that blank, and a 25 is going to go in that blank. All right, so now I have a perfect squared trinomial. How does this guy factor? Just go ahead and write down your parentheses squared. I know it's going to be parentheses squared. We're dealing with r, so it's going to be r, and then what goes in this parentheses is just half of that number, half of b. Half of negative 10 is negative 5, so it factors as r minus 5 squared. On the right-hand side, I just combine my like terms. 15 plus 25 gives me 40. I'm sorry, guys, this camera keeps focusing in and out, but I want this camera to kind of zoom in, so sorry, just going to have to kind of bear with me on the autofocus. All right, so now the last step is to take the square root of both sides. All right, so the square root of r minus 5 squared is r minus 5. When I take the square root of 40, I'm going to generate a plus or minus. All right, so plus or minus the square root of 40. Okay, so now let me pull this up here. R minus 5 equals plus or minus the square root of 40. I'm going to add 5 to both sides of the equation. R is equal to 5 plus or minus the square root of 40. Okay, so now technically, guys, we have actually not taught you the first week of school. We did not teach you how to simplify radicals. I haven't had a chance to personally show you guys how to do that. I will get to that at some point, maybe later in the unit or possibly later in the year. So, but just for right now, know that this is okay. You can simplify the square root of 40. That actually simplifies to 2 times the square root of 10, but once again, since I haven't taught you that, this will be fine with me if you want to leave your answer like this. If you want to convert this to a decimal, then the two decimals are 11.3 and negative 1.3. Both of those would be correct as well. But just know that the square root of 40 also simplifies as 2 times the square root of 10. Okay, so that's number 11. All right, let's move on over to number 12. Okay, cheat sheet again. And this will probably be the last one that I have to do, guys. I'm doing this video during my planning period, and you can see I've got about 6 more to do. So I'm going to work through number 12, and then I'm going to cut off the video. That'll be part 1. I'll finish up with the last 6 problems. I'll make a separate video. I'll call that part 2, but I'll probably have to make that after school. Okay, so let's finish up here with number 12 on part 1 of the video. GCF, no, because there's a C term. Special case, no, because that's not a perfect square. Square root method, no, because there's a B term, there's a middle term. Factoring when A equals 1, are there any factors of 40 that add to 13? What times what gives you 40, and at the same time, what plus what gives you 13? Well, the first 2 numbers I think of 40 are 4 and 10. That doesn't give me 13. The next 2 numbers I think of are 8 and 5. That works. 8 times 5 is 40, and 8 plus 5 is 13. Remember, if you're not good at that, guys, the little calculator trick that I taught you, you can go y equals, type in 40 divided by x, press second table, and you're looking for a combination of these numbers that will somehow get you to a 13, and there it is. 8 and 5 will add to a 13. So this is nice. So when A is a 1, all you got to do is write your 2 factors. Our factors are 8 and 5, so it's b plus 8 and b plus 5. We're setting this equal to 0. The coefficients in the parentheses are 1. That's nice. So flippy flip. -5 and -8 are your answers, and that's all you got to do. All right, so I think I'm going to stop there, guys, for part 1 of the video, and I'll pick it up here when I have a chance to continue. So that's it for part 1, and we'll see you on part 2.